Hello! Today, we will be talking about measures of central tendency for group data. And before we start, hi! I am Martinier Z. De Ramos from BSECE 1A and I will be your reporter for today. The subtopics for this lesson is 1. Define measure of central tendency. 2. Differentiate group from ungrouped data. 3. Mean, median, and mode and their corresponding formulas for group data. 4. Frequency, class mark, class frequency, class interval, class boundaries, lower and upper limits. 5. The frequency distribution table. And 6. Sample problems on mean, median, and mode for group data. Learning objectives. The learning objectives for this lesson is...
Wala! Tulog na kayo!
Learning objectives. The learning objectives for this lesson is 1. Complete the table of frequency distributions. 2. Find the mean, median, and mode of the group data. And 3. Accumulate knowledge as a means of understanding new things. Before we start, let us first define what is measure of central tendency. Measure of central tendency. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. Central tendency is sometimes referred to as central location. Did you know that measure of central tendency is also classified as summary statistics? It is likely that you are most familiar with the mean, also called average, when it comes to central tendency. However, there's more, such as the median and the mode. Measures of central tendency is very much used in statistics. Statistics, given definition by Merriam-Webster, is a branch of mathematics dealing with the collection, analysis, interpretation, and presentation of masses of numerical data. In simpler words, statistics is used to analyze a large amount of numerical data. Before we move on, let's first differentiate group data and ungrouped data. Ungrouped data, which is also known as raw data, is the data that has not been placed in any group or category after collection. Group data is simply the type of data that is classified into groups after collection. For better understanding, let's have this example. Let's say that 9 students took a quiz in math and the scores are as follows: 25, 30, 35, 40, 45, 26, 29, 50, and 45. Based on our definition, ungrouped data or raw data are data that has not been placed in any group or category after collection. So what we are seeing here are ungrouped numbers. These numbers are not categorized in any way. Therefore, we can say that this is an example of ungrouped data. But if we categorize these numbers, like for example, the number of students that got a score ranging from 25 to 37, it is now considered as group data since it is now categorized. With that being said, let's move on with the 3 M's in the measures of central tendency. First off is the mean. Mean, in terms of ungrouped data, is the average of a given set of data. To find the mean of group data, we will be using the formula mean is equal to summation of fx all over n, where sigma or the summation notation is the sum of the item values. F
is the frequency or frequencies. X is the class marks, also known as midpoint. And N is the total number of frequencies. Next up, median. Median, in terms of ungrouped data, the median is the middle value or number in the set of data. To calculate the median for group data, we will be using the formula median is equal to LBMC plus the quantity of N over 2 minus less than CF all over FMC multiplied by I, where LBMC stands for lower boundaries of the median class, N stands for the total frequency, less than CF stands for cumulative frequency before the median class, FMC stands for frequency of the median class, and I stands for class width or class interval. Last but not least, mode. In terms of ungrouped data, the mode is the number or numbers that occur most frequently in a set of values. To calculate the mode of ungrouped data, we will be using the formula mode is equal to LBMO plus the quantity of D1 all over D1 plus D2 multiplied by I, where LBMO stands for the lower boundary of the model class, D1 stands for the difference between the model class and the class preceding or before it, D2 stands for the difference between the model class and the class succeeding or after it, and I stands for class width or class interval. Now, let's give ourselves an example where we can apply these three M's. For example, BSECE 1A took a test in math and the scores are shown as follows. Okay, this seems like a good example. And just to be clear, what we are seeing here is an example of ungrouped data. And before we start creating the frequency distribution table, let us first define what it is and how it works along the way. Frequency distribution table. It is a table that helps us organize data to show either the actual number of observations or observations falling in each range or percentage of observations. It is like breaking the whole into parts for better observations. The frequency distribution table also has range. Range is the difference between the largest value and the smallest value in the dataset. But how do we solve for the range, and why is it important? Well, it's because this will help us determine how many classes we will be using in the table. Now, what are classes, they say? Well, these are the number of categories of equal length that will be used to group the data. When we say equal length, it means the intervals, or sometimes called width or class width, should all be the same. Again, to get the range, we subtract the lowest number from the largest number. So in our example, our largest number is 40. Yeah, 40. And our smallest number is 6. 40 subtracted by 6 will be 34. Now, we divide this by our chosen number of class. I say let's go with 7. So this will be 34, which is our range, divided by 7, and this will give us 4.857142857. Rounding it up to the nearest whole number, we will get 5. This means the interval of each class will be 5. Deciding on the intervals and the number of classes to use will be totally free, and it is up to you. But in exams, the teacher is the one who will give the intervals and the number of classes. Moving on. We now have our class interval, which is 5. Let us now make a frequency distribution table. There! Now we have a frequency distribution table. Let's slowly fill up the blanks. And yeah, let's start with frequency. Frequency, by the word itself, frequency is how many times those numbers within the class appear. To be more accurate, I usually arrange it in ascending order, but this is completely on you.
So if you were me, what would you do?
Siyempre, doon na tayo sa madali, Lods. Huwag mo na pahirapan sarili mo. Dami-dami ng problema, dadagdagan mo pa.
So in our example, let's arrange it in ascending order for better understanding. Now, all we need to do is to count how many times that number appeared. So, for our first class, which is from 6 to 10, we will just count how many times those numbers from 6 to 10 appeared in the data. Let me give us some highlights. We can see that the numbers from 6 to 10 appeared twice in the data. So, we are going to put 2 as its corresponding frequency. Same goes with the 11 to 16 class. They appeared 7 times. Class 16 to 20 also appeared 7 times. Class 21 to 25 appeared 12 times. 26 to 30 also appeared 12 times. 31 to 35 appeared 4 times. And 36 to 40 appeared 6 times. Now that we are done with the frequency, let's hop into class marks. Class marks. To solve for the class mark in the frequency distribution table, we just simply get the sum of the upper class limit and the lower class limit, then divide it by 2. In short, it's the midpoint. So on our first class interval, which is from 6 to 10, we solve for the sum of 6 and 10, then divide it by 2, and we will get 8, which is the midpoint from 6 to 10. Same goes with the rest of the classes. 11 plus 15 is 26, divided by 2 will give us 30. 16 plus 20 is 36, divided by 2 will give us 18. And 21 plus 25 is 46, dividing it by 2 will give us 23. 26 plus 30 is 56, dividing it by 2 will give us 28. 31 plus 35 is 66, dividing it by 2 will give us 33. And 36 plus 40 is 76, dividing it by 2 will give us 38. Next up, class boundary. Class boundary. To solve for the class boundary, we subtract the lower class limit by 0.5 and add 0.5 to the upper class limit. Let's try it. In our first class, we will be subtracting 0.5 from 6 to get 5.5, which is the lower class boundary. Now for the upper class boundary, we will be adding 0.5 from 10 to get 10.5, which is the upper class boundary. Same goes with the rest of the class. Now for the cumulative frequency. To solve for the cumulative frequency, we copy the frequency of the first class and add it to the frequency of the next class. In our example, we just copy the frequency of the first class, which is 2, then add it to the frequency of the second class, which is 7, to get the next cumulative frequency. 2 plus 7, and we will end up with 9. Then we add 9 to the frequency of the next class, which is also 7. We will then be getting an answer of 16. The same process goes with the rest of the class. 16 plus 12 is 28. 28 plus 12 is 40. 40 plus 4 is 44. 44 plus 6 is 50. Next up is fx. As the symbol says, it is the product of f and x, or the product of the frequency and the class mark. So in the first row of our table, we simply multiply 2 by 8. 2 multiplied by 8 will get an answer of 16. The next is 7 and 30. Multiply 7 by 13 and we will get 91. Multiply 7 by 18 and we will get 126. Multiply 12 by 23 and we will get 276. Multiply 12 by 28 and we will get 336. Multiply 4 by 33 and we will get 132. Lastly, multiply 6 by 38 and we will get 228. Now, let's start solving for the 3m's. Let's start with the mean. First, we need to get the summation of fx and the total frequency. So, let's do it. For fx, let's add all the numbers in the fx column. And if my calculation is correct, we will be getting an answer of 1,205. Yeah, it's 1,205. Now, for the total frequency, let's add all the numbers in the frequency column. After that, we will be getting a sum of 50. There, we are finally done with our unknowns. Going back, to solve for the mean, we will be using mean is equal to summation of fx all over n. I will write down the given for you. There. Now, substituting it to the formula, we will then be getting mean is equal to 1,205 all over 50. Simplifying this will give us a final answer of 24.1. That is our mean. For the median, we still have unknowns. So before solving, we will first identify where the median class is using the formula n over 2. Substituting the given, and we will have 50 over 2, which is equivalent to 25. Therefore, the first number in the less than cumulative frequency column that is greater than or equal to 25 is the median class. Since 28 is the closest to 25, class 21 to 25 is the median class. Substituting it to the formula, we will then get median is equal to 20.5 plus the quantity of 50 over 2 minus 16 all over 12 times 5. Wondering where we got 16? I'll show you. Since our median class is 21 to 25, less than cumulative frequency, or also called cumulative frequency before the median class, has a cumulative frequency of 16. There, that's how we got 16. On top of that, FMC, or the frequency of the median class, has a CF of 12. Now that our unknowns are now known, we can now solve for the median. Substituting it to the formula, and we will get median is equal to 20.5 plus the quantity of 25 minus 16 all over 12 multiplied by 5. Simplifying this will give us 25 plus 3.75, giving us a final answer of 24.25, which is the median of the group data. Lastly, we have the mode. To solve for the mode, we need to identify the modal class. In other words, it is the class with the highest frequency. As we can see that there are two classes with the highest frequency, which is 12. So, if you are wondering which one to choose, don't worry, you can choose any of the two and you will still arrive on the same answer. Let's try the fourth class. The first given that we got is LBMO, or the lower boundary of the modal class, which is 20.5. And to solve for D1, we subtract the frequency of the modal class to the frequency of the class before it, which is 12 and 7. Now, to solve for D2, we subtract the frequency of our modal class from the frequency of the class above it, which is 12 and 12. Simplifying those will give us 5 and 0. Let's list it down. Now that our given is complete, we will now substitute it to the formula. We will get 20.5 plus the quantity of 5 all over 5 plus 0 times 5. Simplifying it, we will get 20.5 plus 1 multiplied by 5. 20.5 plus 5 is equivalent to 25.5. Now, let's try the 5th class to see if we will get the same answer. The given that we have are LBMO, which is equivalent to 25.5, which is the lower boundary of the 5th class. To solve for D1, we subtract the frequency of our model class to the frequency of the class before it, which is 12 and 12. To solve for D2, we subtract the frequency of our model class from the frequency of the class above it, which is 12 and 4. Simplifying those will give us 0 and 8. And we will also have an interval of 5. Substituting it to the formula, LBMO plus the quantity of D1 all over D1 plus D2 times I, we will get 25.5 plus the quantity of 0 all over 0 plus 8 multiplied by 5. Simplifying this will give us 25.5 plus 0 multiplied by 5. And any number multiplied by 0 is 0. So 25.5 plus 0 will give us an answer of 25.5. As you can see, we got the same answer with our 4th class. Now for the summary. We learned that measures of central tendency aims to describe a set of data, and it is very useful in statistics. We learned that there are two kinds of data in measures of central tendency, and those are grouped and ungrouped. We also learned the difference between those two datas. Ungrouped data is the raw data, and the grouped data is the categorized data. We then talk about the frequency distribution table and how to solve for its parts. And finally, we understood that the 3 M's are mean, median, and mode, and how to solve for them using their corresponding formulas. These are the references that I used while making this video. And yeah, that's it. I hope you learned something today. The grind was long, but I hope you enjoyed it. If you have any questions, don't be shy to ask. Sabi nga nila, kapag curious ka,
Huwag mahihiyang magtanong kung may right med ba nito, may right med ba nito. Pag may kailangang gamot, huwag mahiyang magtanong kung may right med ba nito.